Okay, so we are now going to talk about how do we compute p-value. So suppose I have a population, okay, I have a population, and then this population has an unknown parameter that's the expected value. This is unknown, and we take some data point from this population. Let's say 3 data point, A, B, and C. We will have a sample mean that is x bar. First, we take 3 data point, n is 3. And what's the sample mean? Sample mean is the average. That means A plus B plus C divided by 3. And then we have a number. And what is p-value doing here? The p-value is doing here is that we now make a hypothesis. Suppose I guess that the mu, I have a mu guess, mu g, I suppose I have value, mu g, and I'm saying that I make the hypothesis that this population actually having the value mu g, and I'm going to calculate the p-value to verify, am I correct? So that's the idea. The p-value in this case will be what? The probability you see data given that the null is true. This is called the null hypothesis. And what is null here? The null is the mu, which is unknown, is equal to the guess value, I guess. And we are going to use the x bar as a way to verify is this true. So what should we do? Now, from previous video, I have derived the formula. How do you compute a p-value? So the formula will be what? 2 times the probability that standard z variable is smaller than this small thing, where small z is x bar minus mu g divided by sigma square root n. This is basically the same as this integral. That is, you calculate the standard Gaussian integral with 0 mean sigma 1, and then you integrate from negative infinity to this z value. The z value is this particular value. And here x bar and sigma are the value we obtain from the data, which is, so this will be the formula. So here, what is this sigma? Sigma is the standard deviation of the population. If we know this value, we just plug in this value. But if we don't know this value, we have to estimate it. So we will use something called unbiased estimator to estimate this sigma, which has the following formula. So the variance, which is sigma squared, will be approximated using the estimator. We denote it as s squared. So this is variance. It will be what? It will be the data point, subtracting the sample mean, and then square, take the sum. Now, instead of divide by n, we divide by n minus 1. So this will give us the s squared. So what will be the s value? So if we have 3 data points, this will be the s value. That is the unbiased estimator of the standard deviation. So we have this s value. And we place this s value into this expression. Then we will get this z value. Then the last step is to compute this integral. Then we will get the probability that the data under the assumption now is true. This expression has the meaning that what is the probability we see the data given that the null is true. And if the probability is a very large number, that means what? That means this is very likely is true, so we cannot reject h0, we cannot reject null. But if this probability is very small, then we say that we reject h0.